Well, hello everybody. I hope everybody is doing well and staying safe. Let's talk some math, shall we? Today we're talking about chords and tangents. This is lesson 21 of Unit 4. Woohoo! Finally, Unit 4, new stuff. Anyways, so the first thing it's going to ask us to do is look at this GeoGebra file. This GeoGebra file. It shows circle X. Circles are always designated by the center point. Circle X with diameter CD, and chord EF has been drawn such that it is perpendicular to diameter CD with intersection at point G. The lengths of EG and GF are also shown. Notice what happens. If I were to change the length of the chord, like if I were to move this chord, oh, it won't let me move the chord. Huh, okay. Move point E. Okay, so E is the only one that can change. Gotcha, okay. So, as long as this is perpendicular, what happens to the lengths of EG and FG? Doesn't take a rocket scientist to figure out what's happening here. As long as this is perpendicular, what can you tell me about these two lengths? There is also a relationship between the two congruent chords in a circle. Review this information below. Let's move on to this next part. This is, oh boy, this is a proof. All right, we have to prove this. In a circle, two congruent chords are equidistant from the center of the circle. Remember, two segments are equidistant from a point if they are the same distance from that point. In the case of chords, this distance is measured perpendicular, there's a word, from the chord. Given AB is congruent to CD, RX is perpendicular to CD, RY is perpendicular to AB is congruent to CD. Reads as, wait, what? See, now here's where I get confused. Why is this there? That's not needed. That's just extra jibber jab to confuse you. As long as you know what this symbol means, which you should, it's been on my board since like week 2. Let me turn that so you're not looking at it sideways. Since like week 2, you should know that that means congruent, because it is both equal in measure and similar in shape. So prove this. All right, let's see. How are we going to prove this? This is the process. I haven't done this yet, so we are going to go through this together. I'm not going to watch this video if I'm stumped. I am going to figure this out. Well, first let's start with what we know. AB is congruent to CD. Can you guys see that? I hope so. Let me move this up so it's more in view. Turn this more so you can see it better. Maybe lower it down. There we go. So I know that AB is congruent to CD. I'll make my statements and my reasons. And if I need room, I'll do more over here. We'll hold off on that. I don't know. I don't know how big this proof is going to be, and I don't know how big the reasons are going to be, so just bear with me. I'm doing this with you. AB is congruent to CD. Oh, and if you ever want to know what erasers I use that works so well, because this does work very well, it's a Black Pearl. No, I am not. They're not a sponsor. They should be. AB is congruent to CD. We have RX. Oh, these are segments. RX is perpendicular to CD. And RY is perpendicular to AB. Okay. All of this given. So what does that tell us? That tells us that, well, since this is perpendicular to this, that means this is congruent to this. So I can say DX is congruent to XC. And I can conclude that AY is congruent to YB. Now, why did I say that is the perpendicular chords that are perpendicular to a radius are bisected by the radius. And if you don't understand that, guys, remember, we just went over it right here in moving all this, right? They stay congruent as long as this chord that I'm moving is perpendicular to the radius being xd, then it is a bisector. It is a perpendicular bisector, okay? So, chords that are perpendicular to a radius are bisected by the radius. Good. What else do we know? So that means that this is congruent to this. This is congruent to this. Now, we've already stated that AB is congruent to DC. So that means that AY is congruent to DX. So AY. No, let's not do AY. Look at how there's a triangle formed here. Let's establish that these are triangles. So we have RB. Nowhere does there say anything about RB. So I'm going to say RB exists. And I'm going to say RD exists. These exist because, what is it? Any 2 points define a line. Okay, and now I can say that RD is congruent to RB. RD is congruent to RB. Why? The radii. Definition of radii. All right, so let's look at what I'm starting to prove. I'm starting to prove that this is congruent to this. This is going to be congruent to this. I haven't proved that YB and DX are yet, but I know that I'm going to. So if you go back to proving triangles are congruent, my class, we skipped this and we revisited it when we did right triangles. There's something called hypotenuse leg. Hypotenuse leg states that if the hypotenuse and one leg are congruent, this is congruent. Now, if you go and look for the proof of it online, it basically says that this squared minus this squared must equal this squared. Pythagorean theorem. So if this is the same as this is the same as this must be the same as this based on the Pythagorean theorem, based on the transitive property, yada, yada, yada. Okay, hypotenuse leg proves it. So now all I have to do is prove YB is congruent to DX. And that'll prove that RY is congruent to RX. And I'll explain how in a minute. So I can now actually say, since this and this are equal, then this must be half of this. This must be half of this. So I can actually say that YB is congruent to DX. I'm jumping all over the map here. I wanted to prove that these are triangles first, but let me just get this side and this side in. Why? Because transitive property. And the reason that's transitive property is if this is congruent to this, then half of this must be congruent to half of this. Now we can say that these triangles exist. Triangle RYB and triangle, now I want to do it in the same order, so I went R90 outside, so RXD, triangle RXD. Those exist. 3 non-collinear connected line segments make a triangle. Don't ask me how I remembered that. Three non-collinear connected line segments make a triangle. Okay, And so now we've got established those. Now I have to establish that these are right triangles, because remember, we're trying to prove hypotenuse leg, right? If they're right triangles, that means RXB must be a right triangle. Now, you would think, oh, well, Mr. Shaw, it's a perpendicular, so it must be right angle. Yeah, no. You can't establish that just by saying that, or just by knowing that. You have to say that. So I'm going to say RXB, angle RXB, and angle RXD are 90 degrees. Definition of perpendicular. Now that I can say that they're right triangles. So, triangle RYB and triangle RXD are right triangles. Yeah, so much for me making this all nice and neat. Are right triangles. Definition of right triangle. Bear with me. I'm going to do something really dirty. I'm going to put this up here and finish it. I'm sorry. So this goes up to here to finish. I just ran out of paper. So we've established that they're right triangles. We've established that this is congruent to this. This is congruent to this because of the radii. Oh, we can do hypotenuse leg now. So triangle RYB is congruent to triangle RXD because hypotenuse leg. And now I can jump and say RY is congruent to RX. Now, why can I do that? You guys are going to love this, remember? CPCTC. CPCTC. I remember trying to show you guys how to say CPCTC, let alone understand what it is. Corresponding parts of congruent triangles are congruent. Now, that sounds like a big duh, and it kind of is, but it's needed. I needed to prove it. So, QED. Quote, erat demonstratum. Hence the proof. Next, finally, you should know the relationship between two segments that are tangent to the same circle and meet at a point outside the circle. I had coffee. I'm so sorry I had coffee. All right. Double click at the diagram above to open it. I don't really need to. Then draw segment AD, AB, and AC. AD. Let me get a little bit of a straight edge going here. I don't know where my ruler went, so I will use a notepad. Little sticky notes. Does it make it straight? Yes, it does. Does it matter? No, it doesn't. I'm not drafting something for a building. It doesn't have to be perfect. Okay. What does it mean of the two segments? What two segments? A, B, and AC are both radii. Okay, so that means they're both congruent. Now, segments are tangent. So tangent lines are 90. What else? You learned... Excuse me. That's why I had coffee. You learned about the angle formed by a tangent circle and the radius is drawn to a point. What does that mean about ABD and ADC? I already answered that. These are right angles. AD is congruent to AD. Now, this seems like one of those duh statements. It is. This seems like one of those duh statements. Sorry, I was watching Deadpool the other day, so I got Deadpool stuck in my head every time he says something and then whispers. So that means this is congruent to itself, right? Well, now we have hypotenuse leg. Here is a review of your options. That would have been helpful back with that, wouldn't it? Whatever. Now that you have proven the triangles are congruent, you know that BD is congruent to CD. By corresponding parts of congruent triangles are congruent. Here it is. C, P, C, T, C. Yay! Jazz hands. More generally, we now say that two segments that are tangent to the same circle and meet at a point inside the circle are congruent to each other. Believe it or not, a lot of farmers will do that. Or not farmers. land surveyors. If there's like a silo on a farm, they'll stand here, measure from here to here, and they know that this is 90 and this is, yeah, whatever. Moving on. Talking about the last section. Use these additional relationships to solve problems. In the diagram, NM, and QN are tangent to circle P. The radius of the circle is 5. MN is 12. Determine the length of PN. PN's not drawn, but I'm going to. This has nothing to do with QN. So 5, 12, 13. This is a Pythagorean triple. 5 squared plus 12 squared is equal to PN squared. So 25 plus 144 is equal to 169 is equal to PN squared. Take the square root of that. PN is equal to 13 plus or minus. Not possible. You can't have a negative distance. What is the length of QN? QN must be 12. Explain your reasoning. Explain your reasoning. There you go. Because if this is 5 again, and this is 90 because this is tangent, we have hypotenuse leg. Corresponding parts of congruent triangles are congruent. Challenge! Woo! That's actually really not that hard. You just have to understand something. If this is 4 and this is 2, that means this is 2. How far is this? 4. What do we use? Pythagorean theorem. Oh my goodness. Not that challenging once you see how to do it. Oh, that's it. Okay. I will have another video for you guys soon.